Hello, my name is Nathan Halliday, and my HPCC Systems intern project has been to implement the parallel workflow engine. The primary aim for this project has been to improve the runtime of ECL queries. The new workflow engine will increase the amount of parallel processing performed by the platform. Previously, developers have optimized the platform at the lowest levels, working on the clusters, so the Thor clusters and the operations they perform. But the parallel workflow engine will enable concurrent processing at the level of the workflow, which is larger sections of the query. The most important data contained in the workflow is the relationships between workflow items, which are called dependencies. These ensure that operations get performed at the correct time. For example, it's no use trying to sort a dataset that hasn't been loaded. The parallel engine has to traverse the workflow to identify independent processes in which executing one will not affect the other, and therefore they can safely be performed in parallel. My project has been divided into three main sections. Initially, I was tasked with understanding ECL and the role of the current sequential workflow engine. Next, I came up with a basic design for how the parallel engine will work. And then the third section was to gradually increase the number of different types of workflow items and modes that the parallel engine can support. The sequential workflow engine traverses the workflow one item at a time and acts so that it always executes each item's dependencies before the item itself. So it uses a recursive algorithm. What I noticed was that the main features of this didn't really require recursion, and it was enough to I'd process all the items and to see the general order in which they need to be processed. And that's described in more detail on the poster. One of the main challenges for the project was to ensure that after starting all the different parallel threads, that they would stop correctly. In particular, if a workflow item fails, then the engine has to go outside of its normal processing, and therefore the algorithm had to be very complete and make sure that there weren't any edge cases where the threads would run forever. Another challenge of developing the parallel engine was when different workflow modes are combined together. I had to investigate the behaviour of the sequential engine to make sure that the parallel engine would be consistent once the modes were implemented. On the poster, I've included a timeline of a typical work unit, and you could get access to the graphic from ECL Watch under the Timers tab. This shows that by the end of my project, I've been successfully able to execute a whole range of workflow items concurrently.